Okay, so we're going to try to find the volume of the area bounded by y, which equals x squared, the line x equals 2 and the x-axis, and we're going to revolve it about the x-axis. Okay, so let's try to interpret what I'm actually saying in this picture. Okay, so if I'm revolving about the x-axis, what type of volume am I going to be looking at here? Okay. So I'm going to go out 1 and 2, and I'm going to go up by square, 2, 3, and 4. That point right there. So it's going to come down. Gets to that point right there. And then we extend this down in this direction. And so that's here. Okay, so I'm looking at this shape right here. It kind of looks like a top. Okay, what I mean by that is one of those spinning tops that you'd spin on the ground. Okay, so what I'm going to do, I'm going to try to make this. This is the volume that I'm trying to create. And so I'm going to do this with dotted lines just so that we can see what it is that we're doing. Okay, so to create this type of volume that we're looking at, what we're going to do is going to take circles. You know what, I'll close this out. Right. Not my best work of art, but what we're going to do is we're going to take circles, and we're going to have these circles start at 2, and the radius of these circles will correspond to the height of the function, and we're going to push these circles all the way down from 0 to 2. Okay? So, the volume of this guy is going to equal the integral from 0 to 2. Now this pi times r of x squared. Now this pi times x squared, that's the height. Now squared an integral with respect to x. Okay? So remember, this just corresponds to pi r squared. Please turn off, please mute yourself because that's getting recorded. All right? And so, this is going to equal the integral from 0 to 2, now of pi, now x to the 4th, an integral with respect to x. Okay. Now this is just the power rule for integrals, and so that becomes pi. Now, x to the 5 divided by 5, evaluated at 0 and at 2. Okay? Well, we don't care about plugging 0 into this thing. We do care about plugging 2 into this thing. And so if I plug 2 into this, that becomes pi times 32 divided by 5. Okay? Give me a second, I want to add one more thing for this video, then I'll answer some of y'all's questions. Okay, so this one is kind of straightforward. It's not really that bad. All right, so, but we don't just have to revolve these about the x-axis or the y-axis. We can actually, we can revolve it around other lines as well. So, let's say, okay, so, same region. Okay, so I'm going to take the exact same region that is bounded by x squared, the x-axis and x which equals 2. But we're going to revolve it around y, which equals negative 2. Ooh. Okay, so let's try to imagine the what we're looking at in this picture. Okay, so 1 and 2, 1, 2, 3, 4. Okay. And so once again, this is y, which equals x squared. And then if I go down 1 and 2, okay, so this is the line y, which equals negative 2. Okay? So I have to imagine that if I'm revolving around this line right here, okay, so if I go down 2 more, and so that guy's going to have a base right there. Okay. So you have to imagine that this is some type of wedge-shaped thing, okay? And so we have to try to think of what am I actually revolving around? I mean, what are the different volumes that I'm creating by doing this, okay? So if I consider the first one, okay, so if I'm going to create this big outer volume with no hole in it, so according to the corresponding height of this thing, we're going to have this distance right here that is going to be corresponding to the length of y, which equals x squared, okay? And then we've got an extra 2 right here because it's bigger, okay? So for this guy, r is going to equal x squared plus 2, right? And what we're going to have to do is we're going to have to subtract the cylinder from the center of r, which equals 2. And what is that going to give us? That's going to give us so, all right, so by increasing the radius, the height, the radius of these circles that we're dealing with, by increasing them by 2, that's accounting for this section on the interior right here. Okay, but this section of the interior right here, that's not the area that's being revolved. It's just being revolved around that line. And so this region right here, the region that's bounded by y, which equals x squared, the x-axis, and x, which equals 2, when that gets revolved around, just that area, then we actually end up with this shape, okay? But if I just take the circles and push them down, it's gonna create the complete volume. So I'm gonna have to say, I'm gonna take the complete volume and I'm gonna have to subtract out this hole in the middle, and then that's really gonna give me the volume that I'm looking for, okay? So, and since, and general rule of thumb is if it's below the x-axis, the region that you're revolving around, it's just addition. You're gonna add in that extra radius. But if it's above, we'll talk about that in a minute, it's going to be subtraction. Okay, so how are we going to do this? This is going to become the integral from 0 to 2 of pi, now x squared plus 2, now squared, the integral with respect to x, and then subtracting the integral from 0 to 2 of pi, now this becomes, well, let's put it within parentheses. Okay. All right. So this is going to become the integral from 0 to 2 of pi. That's going to become, let's write it like this. X to the 4th plus 4x squared, now plus 4 dx, minus the integral from 0 to 2 of pi times 4 dx. Okay. So, pi times, the integral from 0 to 2 times pi times 4 dx, that guy is appearing on the far right. It's also appearing right here. Those two things are going to cancel each other out. And so I would rewrite this problem like this. We can let those 4's cancel each other out. And so this is going to equal the integral from 0 to 2 of pi, now x to the 4th, plus pi times 4 x squared dx. Okay? All right, so this is going to become pi, now x to the 5th, divided by 5, and then plus, this is going to be pi times 4 x cubed divided by 3, all of this evaluated at 0 and at 2. Okay, so this is going to equal, now pi times, all right, so 2 to the 5th is 32, and then divided by 5, and that's 2 times 2 times 2 times 2 times 2 is 2 to the 5th, and so that's 32 pi divided by 3. Okay, so that's going to be 32 pi times 1 divided by 5 plus 1 divided by 3. And so if we did 3 over 15 plus 5 over 15, that would be 8 over 15. And so I'm kind of running out of room here, but let's write it. Well, let's write it below. Times 8 divided by 15.